Hello and welcome you all in our next video where we will discuss today some good problems from our standard books exercise and chapter from the chapter AP. So here today we will discuss exercise 9.2 and 9.3 and I hope you all have gone through your standards books and seen some problems from your books. So exercise 9.1 is quite easy exercise where some sequence is given and you have to calculate the first term and common difference of that series, or you have to write some next terms of that sequence. So that exercise 9.1 is easy. That's why I hope you all are able to solve that questions. Here I have written two questions from exercise 9.2 that I found that maybe you have some difficulty to solve these problems. So I will discuss problem number 10 and problem number 20 second part. Okay. So first we will see question number 10. Which term of the AP 53, 48 and 43? So this is a decreasing AP where D is negative. Next term is lesser than the preceding term. So here we have to tell 53, 48, 43 is the first negative term. Question is which term of this sequence 43, 48, 43 is the first negative terms. Okay, so first of all we are going to solve this question number 10. So here is the solution. Sequence is 53, 48 and 43. Next term will be 43, 48 means difference of -5. So if we subtract 48 or -5, so we'll get 43, and if we subtract 43 -5, so we will get 38. Okay, so this type will follow. This is the sequence, our sequence, and we have to tell what the first number that will be negative. Okay, we have to tell which term, means we have to calculate the value of that term or the position of that term. So here we have first term of the sequence is 53 and the common difference D is difference between a second term and first term. So here the value of D will be 48A2 minus 43A1. So it will be equal to 53 minus 48, that will be minus 5. Okay, so we got first term A and we got our common difference D equal to -5. Now we have to tell first negative term of which term. So suppose the nth term of this sequence is negative. Okay, so first of all calculate nth term An. So we have derived the formula of An as A plus n minus 1 into D. Put the values of A and D because n is unknown here and we have to tell the value of n. So value of A is 53 plus value of n is unknown and value of D is -5. So this will become 53 minus 5 into n minus 1. Okay, this is nth term, and we are assuming that this nth term is the first negative term, that is the value of An is negative, or we can say the value of An is less than 0. The numbers which are less than 0 is called negative. So here the value of An is less than negative, so we can write An is less than 0. Okay, we have value of An as this value. Okay, put the value of An in place of this. So we will write 53 minus 5 into n minus 1 is less than 0, or we can write it as 53 minus 5n plus 5 is less than 0. Okay, so this will become 5n. Take this term to right hand side, so it will become positive 5n, and here 53 plus 5 will make 58. Okay, so 5n, this symbol will go this side, so greater sign is that in right hand side, so 5n will be like this. Okay, greater than 5n is greater than 58. Okay, so if we calculate n from here, we will get n is greater than 58 divided by 5. So if we divide this number, so we will get 11.6. Okay, so we got the value of n as n is greater than 11.6. okay, if n is greater than 11.6, only then the first term an will be the first negative term. If we take here, we cannot take the position of any numbers, or natural numbers cannot be in fractions. So, okay, so these numbers are using in counting, that is these numbers are natural numbers. So the position of any number cannot be like 11.6 positions number. Okay, so if we take 11th term n equal to 11, so the value of n is less than 11.6, so that number, or we can write, if we take a11 in place of a11.6, I know 11.6 will not exist because this position of any numbers cannot be in fraction. A11 is positive and a11.6 is negative. First negative number is a11.6, so a11 is positive, we cannot take it. Okay, we will not take it because it is positive. If we take a12, we cannot take 11.6, but we can take 11, we can take a12. okay, here 11.6 position is not calculatable, and that is the that will not exist. So a12 will exist, and the value of, if n is greater than 11.6, that is 12, only then that will be the first negative number. So in this problem, a12 will be the first negative number. Okay, so we got answer, our answer as a12, or value of n as 12, that is 12th position's number will be the first negative term of this sequence. First of all, we have our sequence. We calculated a and d from this sequence, and we put the value of a and d in the formula of nth term. We just assume that nth term will be the first negative number. So value of an is a plus n minus 1 into d. We put the value of a and d here. We got 53 minus 5 into n minus 1. If an is first negative number, that is less than 0, negative number is less than 0, so I taken here an as less than 0, and next we will write the value of an here, and we got 53 minus 5n minus 1 is less than 0. From here we calculated the value of n as 12. We have not taken here equal to 0. an is less than equal to an is less than or equal to 0, because 0 is neither a negative number nor a positive number. So that's why we have not taken here equal sign, only less than 0 is taken. Okay, so n is 12 is the answer. Next problem is, we have to calculate a number of natural numbers. We have to tell the number, how many numbers of natural numbers between 101 and 999 which are divisible by both 2 and 5. So if we write numbers between 101 and 999, and that numbers are divisible by both 2 and 5, so the first such number will be 110. Okay, 110 is divisible by both 2 and 5. Next numbers that will be divisible by 2 and 5 will be 120, and the next term that will be divisible by both 2 and 5 will be 130. Okay, so in this pattern number will come, and the last term that will be divisible by 2 and 5 both will be 990. Okay, so all that numbers between 101 and 999 that are divisible by 2 and 5 are 110, 120, 130 and 990. Okay, so in this pattern number will come, and this is the whole sequence that will exist between 101 and 999, that is divisible by both 2 and 5. Now we have to tell how many numbers are this type of numbers are. Okay, so here we have our first term. Okay, how I written this number, you can also see these numbers. We have taken 2 and 5 divisible by 2 and 5, so you can take 2 into 5 as 10, and that number which will be divisible by 10, only then that will be divisible by 2 and 5. So I have taken the multiples of 10 between 101 and 990. So these are the multiples of 10 between 101 and 990. So I have to tell here the number of number of terms between this and this, or we have to tell how many numbers are from here to here. Okay, so here our sequence is AP because the difference between these two terms is 10, and the difference between these two terms is 10, and the difference between next two terms will be 10. So this forms a AP. So we can write here A, first term, and first term is 110. We can write A or D, common difference. So common difference is A2 minus A1, difference between second term or first term or any two consecutive terms. Okay, so here D will become 120 minus 110, 120 minus 110, that is 10. So we got the value of D as 10 and the value of A as 110. And the last term we already know, last term is 990. So assume this last term is nth term. Okay, see this last term is nth term and we have to tell the value of n. So here an is 990, and we know the formula of AP is of we know the formula of nth term of an AP is A plus n minus 1 into D, and that is equal to 990. Here we know the value of A, we know the value of D, but we don't know the value of n, and we have to calculate that value. Okay, so this will become value of A is 110 plus value of n is unknown and the value of D is 10, equal to 990. Okay, so we can take 10 here as common. Okay, so if we take 10 as common, we will get 10 into 11 plus n minus 1 equal to 990. This 0 and this 0 will get cancelled out, and we will get here n plus 10 equal to 99, or we will get value of n as 99 minus 10, that is 89. So n is equal to 89, that is the numbers that will be divisible by both 2 and 5 between 101 and 999 are 89 terms. So here these terms are 89. Okay, so if we ask how many numbers are in this sequence, so total 89 terms are in this sequence. Here we have I have written one more question from exercise 9.3, and this question is question number 7th. Okay, so we have to solve for x, and the series is given 1, 4, 7, 10 and up to plus dot 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 last term is x, and that sum is equal to 287. Okay, so there is I have told in classes that the difference between a sequence and series is if the numbers are written in a pattern, that is known as a sequence, and if we add these numbers, if we add the numbers of a sequence, then we will get a series. So this is a series, and we have added these numbers up to x, and we got the sum as 287. So here we have to tell the value of x. Okay, so just check whether this makes an AP or not. So the difference between first and second term, 4 minus 1 is 3, and the difference between third term and second term is 3, and the difference between fourth term and third term is 3. So this is an AP. Now the last term in this series, the last term is x, and if we don't know how many numbers are in this sequence, so there are two unknowns. We don't know the value of n, and we don't know last term x, and we have to tell the last term. Okay, first of all I am just writing an equal to, or we can write an equal to suppose this series have this number is nth position number an. Okay, so we can write an as x, and for this series we have first term a as 1, and the common difference d is a2 minus a1, and that is 4 minus 1 equal to 3. Okay, so we have value of D and we have value of A, and we know the value of an as x. So here an will be equal to a plus n minus 1 into D from our nth term general formula. The value of an is x, so we can write here as x equal to a is 1 plus value of n is unknown, n minus 1 into D, D is 3. So we will get 1 plus 3n minus 3, and we can write it as 3n minus 2. So the value of x is 3n minus 2. And we can calculate from here, we can calculate the value of n. So if we calculate for n, so that n will become x plus 2 divided by 3. So we got the value of n as x plus 2 divided by 3. Okay, so in our earlier classes I have told if we add n term of AP, we will get the sum as Sn, and the formula of Sn was if first term and last term is known, so the formula of Sn was n by 2 if this series have n number of terms, so the formula of sum will be n by 2 a plus l, where l is the last term or nth term. So for this sequence Sn will be equal to n by 2, a is 1 and value of l here is x. So this will be Sn will be equal to n by 2 1 plus x. Now we know the value of Sn here is 287. So put the value of Sn 287 equal to n by 2 into 1 plus x. Here we have two variables, one is n, another is x, but we have to calculate the value of x. So put the value of n in terms of x. So this will become 287 equal to n by 2, or here we have to put the value of n, and that is x plus 2 divided by 3. So here one more 3 and into 1 plus x. So this will become 2 into 3 6. So this will be 287 into 6 equal to, multiply these two terms will make x into 1 x plus x square plus 2 plus 2x. Finally, so we will get value of x square. In right side we will get x square, x and x will make 3x. So here will be 3x, x square plus 3x plus 2, and multiply these two terms we will get 1722 minus 1722 equal to 0. We will get left side there will be 0. Okay, so in our next term we will get x square plus 3x minus 1720 equal to 0. So here we got a quadratic equation, another problem solving techniques which we will you have learned in your 9th classes. Okay, so we have to tell two numbers whose multiplication is 1720 and the difference between these two terms is 3 plus 3. So that numbers are 43 and 40. So I am writing x square plus, in place of 3 we are writing 43 minus 40 and x minus 1720 equal to 0. Okay, so next we will get x square plus 43x minus 40x minus 1720 equal to 0. Okay, so next we can take x as common. So here we will get x into x plus 43 minus, here we will get minus 40 as common, and we will get x plus 43 equal to 0. Okay, so we can take x plus 43 as common, x plus 43 into x minus 40 equal to 0. Okay, so here we have product of two numbers as 0. So that means if the one number is 0 or both number is 0. So if we take x minus 40 as 0, we will get value of x as 40, and if we take value of x plus 43 as 0, so we will get x plus 43 equal to 0, we will get x equal to minus 43. Okay, so we got two values of x from this sequence. As we know, this sequence, this series is increasing AP, and that next term, nth term of this sequence is higher than 1, next term is higher than preceding term, so that means the numbers will be positive and will be greater. Okay, so minus 43 answer is not possible, only x equal to 40 is possible, because all the terms in this series will be positive. Okay, so x equal to 40 is our answer. Here we have one more problem from exercise 9.3, and this problem is from problem number 8, second part. Okay, so question is, how many terms of the AP 24, 21, 18 must be taken so that the sum is 78? Explain the double answer. Okay, so our sequence is 24, 21 and 18. Next term will be 24 minus 3, that is 21, 21 minus 3, that is 18, 18 minus 3 will be 15. Okay, so in this pattern numbers are. Okay, now we have to tell how many terms of this sequence will make sum as 78. Okay, so one thing that is clear here, that sequence these terms are decreasing, this AP is a decreasing AP, where the next term is next term is lesser than the preceding term. Okay, so we can just assume that after some certain position, number will come as negative numbers. Okay, so here it is 24, here it is 15, so somewhere we will get 10, somewhere we will get 5, and somewhere we will get 0, and then number will come as negative terms. Okay, so for this AP, assume that n terms of this AP, n terms. Okay, n terms of this AP makes the sum as 78. Okay, so that means we have to add these n terms, and that sequence will become a series. Okay, so here last term is an. If we add these n terms, we will get sum as 78. Okay, so here we have our first term A as 24. We have value of D as A2 minus A1. A2 is 21 and the value of A1 is 24, so the value of D will be minus 3. Here number of terms are n. The value of n is n, and the value of A is 24, the value of D is minus 3. Okay, so we have the formula of n terms of an AP. So Sn is n by 2 into 2a plus n minus 1 into d, and this Sn is equal to 78, so the put in place of Sn 78. Value of n is n, so this will become n by 2, and the value of A is 24 plus n minus 1 into value of D is minus 3, so in place of D put minus 3. So we will get 78 equal to n by 2 into, here we will get 48 plus minus 3 into n minus 3n, minus 3 into minus 1 plus 3. Okay, so we will get as 78 equal to n by 2 into 48 plus 3, 51 minus 3n. Okay, so multiply these two numbers, 78 into 2, 6 and 15, 156, and we will get here n into 5n, that is 51 n minus n into 3n, that is minus 3n square. So if we arrange these numbers, these terms, so we will get 3n square. Take this term left side, so it will become positive 3n square, and this term in left side, so it will become negative, minus 51n plus 156 equal to 0. So we can take 3 as common here. So we will get next we will get as take 3 as common. So here it will be n square, here it will be 5 3 1 and 7, so 17n, and here it will be 3 if we take 3 as common. So we will get plus 5 into 2, 52 equal to 0. Okay, next this will be equal to 0, or this sequence will be this sum of these terms will become 0, or n square minus 17n plus 52 equal to 0. Okay, now we have to guess two numbers so that the product of that numbers is 52 and the sum of these two numbers is 13 and 4. Okay, so the numbers whose product is 52 and the addition of that numbers is 17 is 13 and 4. So we can write here as n square minus 13n minus 4n plus 52 equal to 0. Okay, we can take n as common here, so it will be n minus 13. Here we can take minus 4 as common, so we will get n minus 13 equal to 0. Now n minus 13 and minus 13, we can take n minus 13 as common, so we will get n minus 4 equal to 0. The product of two numbers is 0, that means either those numbers are 0 or one of them is 0. Okay, so either n minus 13 is 0, that is n equal to 13, or n minus 4 is 0, the value of n is in that case 4. So here we got two values of n equal to 4 and n equal to 13. What this double answer means. Okay, so n is 4 also possible, and n is 13, n equal to 13 also possible. We have sequence as 24, 21, 18, 15 ... Okay, so the first four terms, this answer is saying the sum of first four terms, that is sum of these four terms is 78, and the sum of first 13 terms also will be 78, because next terms here, next term after fourth term 15 plus here it will be 12 plus ... up to a13. Okay, so these terms, sum of these terms, that is here some numbers will be positive and next some numbers will be negative. So the sum of that positive numbers is equal to the sum of that negative numbers. So positive and negative numbers is getting cancelled out. That means sum of 5th to 13th term is equal to 0. That is the sum of these from 5th term to 13th term is 0. That's why the sum of first four numbers is making it as 78. Okay, so n equal to 4 is the answer, and n equal to 13 is also correct answer. So in this case we have two answers as n equal to 4, n is equal to 3rd from exercise 9.3. Question number 15. Question is in an AP, the sum of first n terms is Sn minus n square. This is the sum of n terms, first n term 6n minus n square. Find its 15th term. Okay, so here we have two methods to solve this particular problem. Method 1 is Sn is given, Sn is equal to 6n minus n square. Okay, so this is sum of first n terms, that is Sn minus 6n minus n square, and we have to tell the value of 15th term. Assume the sequence is as a1, a2, a3 ... an. Okay, so the sum is equal to Sn, so we have to add these terms and it will become an series, or this will become a series. Okay, so the sum of these first n terms is equal to Sn as given in the problem. Okay, so if we take here we have n number of terms, and the sum of n minus 1 terms will be as a1 plus a2 plus a3, a1, a2, a3 plus ... last term will be n minus 1. okay, and this will become Sn minus 1. Here we have n number of terms, here we have n minus 1 number of terms, okay. So the sum of n terms is Sn and the sum of n minus 1 term is Sn minus 1, okay. So if we subtract sum of n terms if we subtract sum of n minus 1 terms in sum of n terms, so we will get here this will become negative, 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 and this will be also negative. So a1 cancel, a2 cancel, all terms in between cancel. Here an minus 1, here we also have an minus 1, so this will also get cancelled, okay. All terms are here are getting cancelled out, only last term an is remaining. So this an will be equal to, right side we will get Sn and minus Sn minus 1, okay. So this is the formula. Basically this is a formula of calculating any term, so calculating nth term if the sum of n terms is given, so that nth term will be equal to Sn minus Sn minus 1, okay. So we have to tell the value of 25th term, so this we have to tell the values of 15th term, so n, put the value of n as 15, so we will get, sorry, we will get we have to calculate the value of a 15, so put the value of here 15, so we will get S15 minus S15 minus 1, that is S14, okay. So this will be equal to A15 and the value of Sn is equal to 6n minus n square, so we can calculate the value of S15 and that will be equal to 6 into 15 minus n square, this will be 15 square, and the value of S14 will be equal to 6 into 14 minus 14 square, okay. So this will be the value of S14 and this will be the value of S15. Put here the value of S15 and the value of S14. So we will get S14 as, so we will get value of A15 as S15 is 6 into 15 minus 15 square minus value of S14 is 6 into 14 minus 14 square, okay. So this will become A15 equal to 6 into 15 minus 15 square minus 6 into 14, this will become minus 6 into 14 and this will minus plus 14th square. Now 6 into 15, 6 into 14, take the two terms, 6 in, we can take 6 common from this, so it will become 15 minus 14 minus, take minus as common, minus 1 as common, so here we will get 15 square minus 14 square. Or you can simply multiply these numbers and do calculation. So I am just doing a little easier calculation. So here we will get A15 as 6 into 15 minus 14, that will be 1. So this will be 6 into 1 minus 1 into, here we will get 15th square minus 14 square, 15 minus 14 in one bracket and another bracket we will get 15 plus 14. So this will be 6 minus 15 minus 14, that is 1. So 1 into multiplied with minus 1, that is minus 1. Minus 1 into here we will get 4 into plus 5, that is 9, and 1 2, 29. So answer is 6 minus 29 and this will be minus 23. Okay. So the 15th term for this sequence, and the 15th value of 15th term is minus 23. Okay, so this is the answer. We will solve it from first method, and second method is we can take sum of n, we can put the value of n as 1. So we will get the value of S1, and that S1 will be equal to A1. If we add first term of an AP, we will get first term. Okay, so here if we have value of Sn as 6n minus n square, and if we put in place of n as S1, so that S1 means sum of first one terms, that is first term, so that first term will be equal to a, and put here the value of n as 1, so it will become 6 into minus 1 square, so this is 6 minus 1, that is 5. So we got first term of an AP a as 5. Okay, so we can calculate S2, sum of first two terms, and that sum will be equal to, if the first term is a and second term will be a plus d, so the sum between these two terms will be a plus d. Okay, so here we can calculate S2, and that S2 will be equal to 6 into 2 minus 2 square, and this will be equal to 12 minus 4, and this is 8. The value of S2 is 8. We can put the value of S2 as a plus d, that is 2a plus d. 2a plus d equal to 8. We have already calculated the value of a as 5. Put the value of a as 5. 2 into 5 plus d equal to 8. So the value of d here is 8 minus 10, that is minus 2. So we got the value of a as 5 and the value of d as minus 2, and we have to calculate the value of 15th term. So a15 will be equal to a plus n minus 1 into d. A will be 5, value of n here is 15 minus 1 into value of d is here is minus 2. Okay, so it will be 5 minus 15 minus 1 is 14, 14 into 2, 28. So this will be minus 28. And if we solve this a15, we will get a15 as minus 23. So this was the second method. I think this was easier. So this is all for today, and you have to try these exercise questions, exercise 9.2 and 9.3, and if you have any doubt in any problem, you can send your doubt through any medium, and I will try to solve that. Okay, so thank you.